Hi, everyone. Welcome to the May version of the Julia Beginner AMA. I'm actually really excited for this AMA because we have two amazing attendees or two amazing panelists who both have been working with Julia for a while now and both have amazing contributions. And I'm really excited that they will be here to answer your questions. I will be on and off on the call. If there's anything I can contribute to or help moderate with, I will do that. Just a quick housekeeping comments. First of all, if you want to post questions, we already posted the link to the Pigeonhole Q&A platform, which basically has, you can just post your questions there, and people can upvote them, and that way, the most upvoted questions will show up at the top. I will also keep an eye on the YouTube chat so that I can answer questions that require possibly links or anything like that, or point out if there's any question posted in the YouTube chat. And aside from that, I will just leave it up to our panelists to start answering your questions. We have Alex with us today and Xuan, and I will turn the microphone to them. Alex and Xuan, if you want to introduce yourselves a little bit in the beginning, and then we can start taking questions. Xuan, do you want to go first?
Sure. Hey, everyone. My name is Shen. I use they, them, or she, her pronouns, and I'm a second-year PhD student now at MIT, where I primarily code in Julia for my research, and that's also where I started learning Julia, partly from Alex, actually, who was also in the same lab. I primarily, I guess, work on probabilistic programming, but the intersection of that, I think, with cognitive science and also AI-based planning. So in the course of that research, I ended up contributing a couple of Julia packages related to classical logic programming like Prolog and also classical AI planning. I'm happy to talk more about those things if you're interested. I guess Alex?
Yeah. Hi, everyone. My name is Alex. I am a third-year PhD student in the same lab that Shen is in, the Probabilistic Computing Project at MIT. Before that, I was a high school computer science teacher. Like Shen, I use Julia in a lot of my research work. I really like the fact that it both has a wide range of sort of scientific computing libraries and capabilities, as well as it makes it really easy to do metaprogramming, which is useful for our research, which involves coming up with new ways for people to encode probability distributions and other and models, as well as inference processes into computers. So Julia has been a lot of fun to learn. I'm still a beginner in some ways. I've used a part of Julia really heavily, and parts of it I haven't used as much. I'm excited to hear people's questions and see how the conversation goes. Thanks.
All right, sorry, I was muted. So it seems like actually the Pigeonhole link is not working. Thanks for pointing that out. Multiple people have pointed that out. I will be working on fixing the Pigeonhole link and posting it in hopefully a couple minutes. But meanwhile, why don't you post your questions on the YouTube chat? And that way, both Alex and Xuan will be able to see them, and we'll start with the questions from there. But I will be fixing the Pigeonhole link and posting it shortly. So with that, so I don't see any questions yet, just because I think everyone was saying that the link isn't working. So maybe I'll just kick off questions with just one generic question to both of you. And I think Alex already touched on that. Just very classical question that everyone asks: what is your most favorite thing about Julia? And what is, if you ever want to pitch Julia to one of your coworkers or collaborators, what's the one thing that you'd be like, that's it, that's the cool thing?
I don't know if you have an answer in mind, Shen, but
sure. I mean, that's an interesting question, right? I think also there are different questions. Like what I most like about Julia may not be how I try to say it to others, because I think what I've come to like about Julia is all the weird fancy things that you would never have heard about. I think in other languages, like multiple dispatch turns out to be super awesome. I think once you get used to it, but it's really hard to even explain what that concept is. I think I took a while to learn how to use it, and write, move away from an object-oriented paradigm to use writing interfaces and classes in Julia. But it's something certainly I've come to love how clean in some ways it still is, and I think multi-purpose. And the other thing, like you mentioned, is definitely the metaprogramming and the fact that the language is sort of just-in-time compiled, which comes with its quirks, but certainly makes things not only faster, but I think really powerful in a way that, I don't know, it's possible that I used to use Python the most before this, but I've never really played around with its metaprogramming features. So it's possible that Python could do something similarly powerful. But the fact, I don't know, the weirdest thing I've done in Julia that for a good reason was write a function that compiles specialized versions of itself. And I don't imagine I could ever do that in most other programming languages. So that's it for me.
Yeah, I think you're right that sort of how you want to sell Julia depends kind of on what pain points the person that you're talking to is familiar with. I know one of the selling points for Julia often, like at a very high level, is you can write loops and they run fast. In machine learning, we're used to having to vectorize all our code to make it run fast, and in the kind of Bayesian inference work that we do, the algorithms that we run often involve kind of complex control flow that we're able to write kind of naively in Julia and still have it not run slowly. But I think once you get a little bit deeper into the language, it is things like the multiple dispatch and the metaprogramming that really make Julia special for me. And one way of thinking about multiple dispatch that I've heard people in the Julia community talk about, and also just more generally that people may connect with even if you're a beginner to Julia, is that there's this thing called the expression problem in programming languages, which has to do with what types of extensibility modules have. So if you implement a class or something like that, if you implement a class in a library, how does someone extend your work? They can subclass your class, and that allows them to add new sort of implementations of a same interface or something like that. But they can't necessarily add a new interface method. They can't add a new method so that all things in your class, all objects of your class or all instances of your class implement that method. Whereas in some other languages, it's really easy to add new methods. Like if you've used Haskell or something like that, it's really easy to add new methods on a type, but you can't add new cases or new types. And in Julia, it's really easy to do both. And so you get this really cool interaction between a bunch of different packages in the Julia ecosystem.
Yeah, I just want to echo that, because that functionality, the ability to extend existing packages functionality, is certainly something I've used in the past. It's a lot of how I think good Julia libraries are designed, and it's, I think, a great way to facilitate code reuse at a level that I don't think I've experienced before in other ecosystems. I certainly have seen like other people selling Julia in terms of like, look, we could do this really complicated thing that would have taken its own whole package in Python. That was just like, no, I'm going to like download these few packages from the general registry and write a script that composes them together. And they tend to compose, really well.
Wonderful answers, honestly. I also have a quick update about the Pigeonhole link. It's now working. So everyone can post their questions there. That way it'll be easier to look at the questions and sort them, and for Alex and Xuan to pick the answers to the questions to answer them. But meanwhile, there were a couple of questions on the chat, and before we possibly start populating the Pigeonhole Q&A platform, we can possibly take a look at the chat and pick some of the questions that are there if any of you is interested in answering them. Do you have access to the Q&A? Okay. So let's see.
I see how long.
Go ahead. Yeah.
Oh, I see the one that says to Xuan, how long did it take you to learn Julia, and how good do you feel about Julia now? For me, the learning of Julia never ends.
Yeah, I think I certainly agree with that sentiment. I think I'm still learning it. I think where I started, I guess, using Julia August 2019, really, and definitely I think it took the entire semester, that about 6 months to really like feel like I got the hang of it, knew how to. I remember my first few things was like, how do I break code into different files and like structure a project? Like I couldn't wrap my head around it. I was like trying to do it the Python way with the init files and everything, and that took a bit to learn. But I think at this point, I think by middle of the next semester, so like maybe like 8 months after that, I managed to, I think, write my first version of a very simple like library, and get that register. And I think that's when I felt like, okay, I've like done enough to like contribute something to the wider Julia ecosystem, and feel good about it. So and since then, I think I've been continual process learning about things like performance engineering. Like there are all these like tiny performance tips that are not immediately obvious when you first write a Julia script or a library, that you have to go into some detail to like get used to. And I think Huda actually has done an amazing talk about this at JuliaCon, about like the little things you can get into to make optimizations. And I've personally, over the past year, like this classical logic programming called Julog library I developed, made it, I think, somewhere like 10 times faster by just like carefully redoing and like re-implementing certain functions to take into account these performance tips. So those kinds of things, I think, took a while to learn, and I think I'm still learning them.
And I just posted a link to Julog if anyone is interested to actually take a look. There's already questions on the Pigeonhole. I think we can now just like officially switch gears to Pigeonhole. If we've missed any questions from the chat, please post them on Pigeonhole. It's just a more concentrated place to look at the questions. So Alex, do you see anything you might be interested in answering?
Well, I see. How did each of you get your start contributing to Julia open source software? I think, I started writing Julia in the context of our lab's research, so I could sort of, it was easy to be integrated into a community that was already using Julia for something and just contribute to that project. But I think one of the things that's been really nice about Julia is how open and welcoming the community is on both sides here. So on the side of like package developer, there are a bunch of people on the Julia Slack and the Zulip and like various other platforms that will like enthusiastically offer encouragement for people learning Julia, developing packages that people will actually like download and try to use your package. And I think there's just like a really nice and I think Xuan can talk about that a bit more, having written maybe a couple sort of more standalone packages. But also, there's just been a lot of interest from other people in contributing to like the open source projects that I'm involved in, which has been really cool to see at various levels of like familiarity with Julia and of the code base. So I think the Julia community is a really great one to get involved contributing to. I don't know, Xuan, do you have thoughts on sort of the open source, the Julia open source world, and like how to get started contributing to it?
Yeah, I think one thing I really like, I haven't, I feel like engaged as much with the community on Slack and Discourse per se, but I do think one thing that sort of infrastructurally that really helps is that all the packages, or pretty much all of them, are hosted in GitHub, and that's also how the package management system works, that you just have a, you can make a new repository on GitHub and then like just tag like one of these GitHub bots, and then you can register your package. And I think that makes the ease of entry a lot, but lowers barriers to entry certainly, and just like uses tools that are already familiar to people, and makes I think new packages a lot more discoverable as well. So I think that's one thing I certainly have liked about how the Julia ecosystem is structured. I know there are hiccups across, it's this fast evolving language, and package management is still being worked out, but I felt it was like easy to get that started.
There's a couple of questions. There's a question on incorporating already available projects. There's both of you are in academia, and I know in academia there's a lot of previous code bases that other people in your lab possibly have like finished a project that you might want to build on or something. Do you have any experience with that? And
I have more experience incorporating existing code into Julia projects than trying to expose Julia code to other languages. I mean, I've used Julia from Python before, but I haven't tried to write C code that calls Julia code. I don't know if you have any experience with that, Shen or Huda.
Yeah, I personally haven't had tons of experience. I think more, again, like Alex, more the other way around. A couple of projects I have, there's like, so because so many people use Python, there's a lot of need to make them interoperate. And that's where I think there have been some pain points because of like making sure the environments are managed right and like installing the right packages has often been an issue. And apparently, I don't know, I haven't had this experience directly myself, but I know like once you try to debug from Python code from PyCall, that doesn't work very well, which sort of makes sense since it wasn't designed for that. But if you're having code base which are really like cross-code, cross-language in that way, multilingual, I guess it can be difficult. When it comes to, I haven't, like Alex said, used Julia from other languages, but I think one thing I noticed actually when I was writing, Julog, which is like attempting to do Prolog in Julia, I noticed I was trying to search with anyone already had already done it, so I didn't have to reinvent the wheel. I think people have actually, quite surprisingly, have like there's this alternate thing where you can use Julia from within Prolog to like do fast numeric computations and stuff like that. So I think certainly that stuff exists out there.
Amazing. Feel free to keep picking questions as you see them coming. I will I will just keep marking things as answered or unanswered. But if you see something that is immediately talks to you, just feel free to pick it and answer it.
See one. Do you use higher order functions in Julia? Stephen Johnson says that they are often a much better tool than macros. So I definitely use higher order functions in Julia and macros, and I think they serve sort of different roles. Higher order functions are useful for a lot of different things. They're functions that take in functions, and we often write macros in our work that expand to higher order functions. So it's not really something that's separate from macros. Where macros are useful is maybe we can sort of tackle this what is probabilistic programming question at the same time. Shen and I work in a lab where we develop probabilistic programming languages, which are programming languages where when you write a function in the language, we think of it as defining a probability distribution rather than just a function. So that might not sound that weird. You can write programs that that generate random numbers, and then we're just saying we're going to, if you write a program that generates random numbers, we're going to interpret it as a probability distribution. You can think of it as any program that makes random choices induces a probability distribution over all of its possible executions. But if you write a program like that just in Julia or in Python or whatever, all you can do with it is run it a bunch of times. So you could run it a bunch of times and try to characterize the distribution of the output by plotting a histogram or something. But we want to be able to take a piece of code that defines a probability distribution by sampling from it and automatically compile other code that does things like evaluate the probability density of that distribution or perform Bayesian inference in that distribution. And what macros allow us to do is when someone writes their program that makes random choices, we can write code that instead of just receiving that as a black box, which is what we'd get if it were a higher order function, we can write code that takes in the source code that the user wrote as data. And Julia has a really nice to work with expression data type that we can then process and manipulate and produce new expressions that implement these density evaluators and other sort of tools for Bayesian inference. And that sort of thing you can't really do as higher order functions. Now, Julia is a little bit weird in that once you get one of these black box functions, like if you're writing a higher order function and someone passes in a function to you, normally when we think about higher order functions, all you can do is run them. But in Julia, you can do weird things where you can like get the intermediate representation or the compiled for so there Julia, because Julia is so expressive, it lets you do things with compiled functions that you couldn't do in other languages. But I think the high level point about sort of macros still being useful even when you have higher order functions, and often really useful to use with higher order functions, still stands. Xuan, do you want to add anything?
I love that answer. I think just to echo, I think certainly macros where I found them most useful are when I want to implement things like alternate syntax, right? I think that already is supplied with a lot of like synergy. Like even think of like string macros. I don't know how many people use this, but regex expressions are so easy to write in Julia just because you just add an R in front of your open and close double inverted commas, and then you can use regex, right? And certainly that's what I did for the Julog code base. Like you could use Prolog-like syntax in Julia in a way that makes it just so much easier for people already familiar with Prolog to switch to that, right? But yeah, I do want to, and I think, with the work that we work on in our lab, we have this probabilistic programming system called Gen that makes it very easy to use, like, to write, functions that look like probability models in a little bit like statistician's notation, instead of making rand calls, and it makes it just easier to write out those models, and then you can interpret Julia can do interpretation in various ways for you. Of course, like Alex said, like Julia is so expressive that you can sort of take in a pre-existing function and decompile it oftentimes to its sort of intermediate representation. And I actually have, I think, done some work in that direction. There's this system that I worked on with McCoy Becker called genify.jl, which tries to take arbitrary sort of stochastic Julia code or functions and turns them using metaprogramming into generative functions controllable like by a probabilistic programming system like Gen. But the issue there is that working with Julia's intermediate representations can be a lot more complex. There are things you can do more easily with the surface level syntax that are a little harder to do with the intermediate representation. For example, you can't tell whether they're loops directly there. You have to detect them yourself and then transform them. So that's one reason why I think if you're really trying to do really complex program transformations, higher order functions they're definitely harder to work with.
There's a very popular question. I don't know if you want to answer it, or if you've already talked a little bit about it in the beginning. It's your choice.
You're referring to what would you say is a key part of your Julia workflow that you think could help others most, yet many people miss?
Yeah, that's an interesting question.
Yeah, I don't know. Off the top of my head, I don't know whether there's anything. This is something people miss, but I think so I still use the old Juno IDE. I haven't switched over to, I presume they're similar. What is it called?
VS Code.
VS Code, yeah, the Julia extension. But I presume there's similar functionality of like recompiling particular functions that you've written, which I'm sure most people use as a very efficient part of their workflow. Which is, you've written a package, but you need to edit a certain thing. You can just recompile that. One thing I really like, though, is that, and people may not realize, is that when you're depending on upstream packages or code, and there's an error in that code base or some issue in that code base or something you need to debug in that code base that's not code you've written, you can also recompile that function in that code base upstream, right? Because you have a local copy on your computer, and see how those changes affect your code in case you want to fix a bug up there or just print out some debug information. And that's been really helpful sometimes in addressing some unexpected coding errors or upstream issues that I realize that I'm not, aren't caused by my script itself. And sometimes it's just I need debug information that isn't available from the output of the function itself. So I need to add like little print statements or et cetera within the upstream function. And that's been one really helpful, I think, aspect sometimes when debugging. Of course, I could use a debugger, but I really don't have much experience with that.
Yeah, that I think you're talking about the revise package, which is right, the one that reloads.
You actually don't need revise to do that. You can do that in Juno directly without using revise.
Oh, cool.
Yeah.
Cool. Yeah. Well, I definitely think like, yeah, revise and other methods of like being able to work in one long-running REPL or like one long-running Julia instance and just like edit your code and have it automatically be reloaded is super useful, and I think probably a pretty widespread Julia workflow. I also, think the profiler and all of those like little macros that you can put in front of your code at time, at btime from benchmark tools, at profile, at code_warn type. Like there's just a bunch of features that I'd encourage people to look up that sort of let you investigate what might be slowing down your code. And the debugger is also nice in terms of just like being able to step through your code and inspect state if you're familiar with debuggers from other languages, it's pretty similar. I think, I don't know how much is unusual about my Julia workflow. I certainly like when developing macros, I always use the macro tools package. It's super useful. And also, I develop bit by bit. It's easy to sort of, especially if you're not constantly working with the Julia AST, it's easy not to really know what a certain piece of code is going to look like. And so I like frequently write just, part of the processing that's going to happen in a macro, and then like have a few like example programs that I want to work at the end of everything, and just run macro expand on them to see what the current syntax processing is doing to that code. It's kind of like having a little like temporary set of unit tests, but without having to think through like what would the unit test be for this code.
Yeah, just to build off on that a little bit. Yes, definitely. Those macros are super. That btime for performance testing, profiling. I think one I took a while to discover was that there's the profile tool itself, which like gives all this text output. But I think if you're using Juno, and possibly if you're using VS Code, there's like a Juno.app profile, and that will open up within Juno a flame graph that shows you like which parts, which functions, which methods you're calling, which are taking up the most time. And that's really how I have like zeroed in on like what are the bottlenecks in my code. So I'm not spending time performance optimizing functions that really are irrelevant to make faster, and like really focusing in on the ones which are taking up the most time. And that's how I got this 10x speed up on this piece of code I was optimizing for Julog.
Yeah, there's also in the text output for profile, there's like multiple formats that you can ask it to print in, and one of them is flat. And I find that pretty useful often because it aggregates calls to the same function, as instead of like, normally you'll be looking at your profiler output and maybe there's like some function that's at the bottom of a call tree that's expensive. And it's, when you're looking at the output in that way, you'd have to find it in every time it was called. But if you do format equals flat, you can see all of the times that it's called all aggregated.
I'm seeing two questions I want to respond to. One of them maybe first, because one of them is specific to me, but one of them I think most voted right now is giving people a hint how to get started with Julia with no previous programming experience. That's a great question. I don't know. I think Alex, as a teacher, maybe has better answers. One that I haven't benefited from myself, but just off the top of my head, is that MIT actually does teach this course called Introduction to Computational Thinking. You can check it out, I think, at computationalthinking.mit.edu, which is taught by, I think, one of the founders of the Julia lab at MIT. And I think it probably is a really great way to learn about the scientific computing with a programming language like Julia, and probably is a great way to get exposed to using the Julia language itself. Alex, I'm not sure if you have any other resources to share on that front.
Yeah, I think that the Julia documentation is quite nice. It's not necessarily like the best beginner resource, but it is quite detailed. And yeah, otherwise I was going to say this course that that was recently taught like by several people. I know that the was it three blue, one brown, Grant Sanderson, is that his name? YouTube channel. I know that he was part of this course, and I've heard great things about it. So I'd recommend checking that out. And also join the Julia Slack, or the other places in the Julia community. There are channels to ask questions, and people are really responsive. I've learned all sorts of really useful things by just asking questions.
Yeah, and I think this other question that was probably directed at me, why did I decide to create a package for Prolog syntax in Julia? Why is it better than using Prolog all the way along? And in fact, I think if you're looking for the fastest implementation of a declarative, logic programming, you should still use like one of the existing C Prolog, like SWI Prolog implementations out there. I have done, I think, performance comparisons, and they're still like a lot faster because I think they're doing compilations, which I haven't had the time or perhaps ability to implement. The reason why I wanted to write a package like Julog is because I did want to be able to just have a purely native Julia native interface that I could and access to the data structures that would allow me to manipulate them, and I think that makes for certain kinds of integrations that were a lot easier than if I had to go across this like process barrier of calling out to a separate Prolog library. For example, one thing you can do with Julog.jl that you can't do with Prolog is that you can, embed like custom Julia functions into your Prolog expressions and like run them within your when you're doing your proof search within that that function, which tries to derive certain facts. And yeah, that's just one example. The other thing you can do is you can, I think, but this is more a parsing feature, right? But you can sort of splice existing Julia variables into your Prolog expressions by using Julog.jl. And I could imagine that you could then send those off to like a actual Prolog engine. But those were the things that made using Prolog in downstream applications like classical AI planning, which works with classical logic a lot easier.
Yeah, and I don't know to what extent this would be true of of Prolog, because I don't know if the results of Prolog programs ever depend on like continuous variables. But I feel like one reason that it can sometimes be nice to have sort of Julia like homespun implementations of things that maybe you could still find elsewhere in another language is that there are a lot of Julia libraries, and I was thinking in this case particularly of like automatic differentiation libraries that will sort of automatically work on Julia code, or often automatically work on Julia code. So if you are using automatic differentiation and you use Flux, everything will just work. Whereas if you use if part of your computation calls out to Python, that's less clear that it's going to work, or calls out to Prolog or whatever else. Maybe like a more general version of that is there are all sorts of benefits to having everything in one programming language. And so if you want to design a computation that uses both sort of Julia code and Prolog code, it's nice to be able to keep the Prolog code in the Julia world, both for the reason that Xuan mentioned of wanting your Prolog code to call Julia, but also for wanting your Julia to call Prolog code.
Yeah, and I mean, go into more detail, like the specific integration. I think when I first started grad school, I had this like really ambitious project of like trying to learn like first order logic theories of like the rules of like games, basically in a Bayesian manner. And so that would have required being able to express. So that project didn't really pan out, but it did require being able to write, access the data structures of expressions over like logical statements like this and that, right? And I could do that in like, standard Julia syntax, but the kinds of game rules I was considering, and you can think of things like card games, for example, seems more easily expressible in things like in classical logic. And also I later realized what are called action logics in classical planning, where you have a bunch of preconditions that have to be satisfied before a certain action can be taken, and that action makes certain facts about the world true. And I want to be able to express that, so I could write Bayesian priors using probabilistic programs over that really complex structured space of rules. So it would have been hard to do that with, I think, just working with the original Prolog code.
See this popular question. What do you think about the Julia community? Is there a possibility that Julia grows their community and has more ML and data science libraries like Python in the near future? And I think one thing that I hear in the question that may not be one thing that I hear in the question that I've heard a lot before is kind of this sense that Julia is a really cool language. It has a bunch of really cool language features. It makes sense that you'd want to use it, but like, aren't we tied to Python because all of our libraries are there? And I think one thing that misses is that there are a number of libraries that you might actually want to use Julia for that you couldn't get elsewhere. So to some extent, I think the answer is there already are certain kinds of like ML and data science libraries like Jump and differential, like the differential equation stuff, and I'll plug the probabilistic programming stuff too, that there really isn't a great alternative to, or I think you can find best-in-class examples in the Julia ecosystem. Now, that doesn't mean that every possible ML and data science need is in Julia, and there are certainly benefits of working in a language where there's obviously like a much bigger Python community than a Julia community, just in terms of number of developers. And so I think Julia does a really good job of attracting package authors. It's a really nice language to write packages in. I don't know enough about like the current trajectory of sort of how everything is developing in the Julia ecosystem to say what's going to happen in the near future. I don't know if Xuan or Huda have more thoughts on that, but I think it's already at the point where for each particular project, or like the calculation that I'd make is not so much, I want to use this language, but I want the libraries here. I often want the libraries in Julia and feel the lack of them when moving to Python.
Yeah, I think, just add on to Alex's point, there's certainly a lot of things that don't exist in Python that do exist in Julia, like the stuff we work on, like in Gen and stuff. Just an illustrative example. It's funnily enough, so I wrote Julog, and then I wrote this follow-up package, pddl.jl. PDDL stands for the Planning Domain Description Language, which is the sort of like standard language used in classical AI planning, symbolic planning, where you're trying to do write automatic solvers for planning problems, like how do I stack up a set of blocks that spell out a certain word, given that I have this sort of symbolic specification of that. And someone who wanted to have a PDDL parser ended up calling my PDDL Julia library to do that, because all of the, I think, Python libraries that they had explored apparently weren't very good. So I think just one sort of maybe like very niche example that's nothing to do with data science and ML all, but certainly on the other hand, I think most of the biggest machine learning and data science libraries do have like already like glue Julia libraries. Alex himself has, I think, worked on one of them. For our purposes, we were interested in using deep learning tools within probabilistic programming systems. So Alex worked on this package called Gen PyTorch, which basically allows you to write PyTorch code and use it within as a generative function, as a probabilistic program within Gen. And those things are fairly straightforward to do because of the existence of PyCall. So my thought is that, I think there's some hiccups, but it feels like the Python ecosystem is mostly accessible from within Julia if you're missing out on those tools. And then furthermore, I think Julia has special things that and that Python, at least right now, doesn't seem to really have. I do think one potential issue, and I think it's seen it a little bit in like sort of my short usage of Julia is that because we have less users, a lot of our packages are still community maintained or maintained by individuals, and that can lead that isn't always sustainable, especially if someone decides to step back from maintaining a particular package. And I think one thing that Python has got a lot of support from is the corporate sector, of course, and that's why you have a lot, I think, more production-ready code bases that for both deep learning and data science. And one thing I would love to see, of course, is that I think more company and tech corporate support for Julia libraries to ensure they're well maintained and have so that it doesn't all fall on a couple of people to like maintain this like widely used package. So hopefully Julia will go in that direction, but remains to be seen, I guess.
There's that question on probabilistic programming, and I feel like you two are great candidates to answer this question. Does any of you want to comment on it?
I feel like Alex is more the expert here. I guess we did a little attempt to answer to some degree, but I don't know if you want to do another version of it.
Sure. I think you can motivate probabilistic programming from a couple different directions. And also, I think, you ask, why are there so many packages for it in Julia? And I think they're all trying to get at like maybe a slightly different corner of the space. Shen and I, when it's not COVID time, we sit in a cognitive science building. So why is a cognitive science building doing probabilistic programming? That's one angle that we can motivate it from, which is that, a lot of tasks that sort of intelligent tasks that we might want a computer to perform or that a person performs can be framed as Bayesian inference in some generative model. So what does that mean? It means that you can write down a probability distribution, which, in a very probabilistic programming way, we can think of just as a program that simulates something, right? So we can write down a program that simulates something so that the task that we want to solve becomes a question about that probability distribution. So for example, if the task that we're trying to solve is speech recognition, we could write a program that randomly generates English sentences and then randomly generates audio of those English sentences. And then the question we might ask is, given this audio, what program executions are consistent with this being the audio that came out? And if you think about, like, very naively, just running the program in a loop over and over and over again and checking every time you run it, does the audio that we heard match the audio that was produced by the program? And if not, throwing it away, and if so, keeping it, then what you end up with is a bunch of English sentences that could be the explanation for this sound that you just heard. For a simpler statistical task like linear regression, we can also frame it in that light, where I write a program that randomly generates a slope and an intercept of a line, and then randomly generates a bunch of points along that line and returns the slope, the intercept, and all the points. And then I throw away anything where the points don't agree with all the points that I've observed, and what I'm left with is good slopes and intercepts for my line. Now, the procedure that I'm describing is very slow, right? And like probably would never work. We're talking about randomly happening to generate the right line, then happening to generate all the points that you observed in your data set. But if you write down a program, this like simulator program, there's a lot of smarter things we can do by analyzing the code of that program to more efficiently find the executions of the program so that the output agrees with your observations. And so we've done work, people in our lab have done work where, for example, you write a program that randomly generates 3D scenes, and then you observe a depth image of a 3D scene. And by conditioning on that depth image, you can get out explanations of the scene in terms of, what are the objects, what are their poses relative to each other, which objects are on top of which other objects. I've worked on a package called pclean.jl, where if you have a dirty data set and you want to clean it, you write a probabilistic program that basically generates randomly a ground truth database of objects and relationships, and then simulates the process by which that ground truth database becomes a dirty data set. And the language pclean is going to look at your program, and because it's in this like nice DSL, it usually only takes like 50 lines of code to write down. It's going to look at that program and your data and try to recover what this ground truth database is. So we ran it on this like Medicare data set of 2.2 million rows and got out like a relational database, a clean relational database of 1 million physicians, like, 400,000 medical practices, 400 medical schools, it sort of extracted all the different objects that were present in the database along with their like clean metadata. And you can then flatten that back into a data set and use that to clean the original data set. So there are a bunch of different tasks that we're sort of excited about solving this way because it's a very general paradigm. And probabilistic programming tools are what let you go from a program that represents this generative data process to a different program which represents the inference process, the sort of backwards process of going from observations to explanations of the data using tools from computational statistics. Now, there are other ways into understanding what probabilistic programming is. That was a very sort of like AI cognitive science inspired one. There are versions that say, scientists in lots of different domains use Bayesian statistics, and they use Bayesian statistics by like coding up a bunch of like Python or MATLAB code after having done a lot of math by hand. Wouldn't it be nice if they could just write down like a 5-line piece of code that reflects what's written there in the textbook, or that reflects how they think of their model, and then just automatically like do the kind of statistical analysis. And that corresponds to the kind of linear regression based example that I was giving earlier. But you can target your tools at these different purposes. So I've said a lot, so I'll stop there.
Thanks, Alex. I think that was such a thorough explanation. I always love it when you try and describe probabilistic programming. I'm going to take like there's going to be some like questions in the YouTube chat. About my pronouns. I mentioned at the start, I use they, them, or she, her pronouns. So those are mine. I also want to flag that it can be a little awkward to be speculating about people's pronouns. So like in general, I'm happy to share them, but like, just FYI that not everyone always is. So yeah, but I just wanted to add to that, I think really excellent description of probabilistic programming, maybe from more from the angle how I use it. I think, I think firstly, a more broadly applicable context, right, which I think is that you can think of probabilistic programs as just a really rich way of specifying Bayesian models, right? If you've studied any kind of things like Bayesian networks or graphical models, those are a fairly restricted class of specifying probability distributions of how variables relate to each other. And you can think of the sort of like natural generalization of that as well. Why not have programs which make random choices, which can specify Bayes nets or other kinds of probabilistic graphical models, but can also have much more complex things like for loops in them. And one sort of very classic probability distribution you might be familiar with, like the geometric distribution, which is like flip a bunch of coins a lot of times until you would see a heads. That can actually be written as a probabilistic program, as a recursive one, in fact, where each time you like flip a head, flip a coin, and if you don't get heads, you call itself again, right? And so you can think of a lot of these. Once you can think of like a sort of generative process by which some event happens, you could, write a program for that. And I think there's some cases where, you have to be careful about semantics, and Alex actually has worked a lot on this, but that's what probabilistic programs are. And then, like Alex said, you want to do a lot of things with them, like doing inference, where you condition on the output of the program or certain variables in the program taking on certain values, and then ask what the other variables must have been like. And it's really useful when you're doing things like in cognitive science. One thing we're interested in is like, how do humans perceive the world, right? Maybe we can write one theory is that we have like sort of intuitive generative models of what the world looks like. Like there are objects out there in the world with different poses, and then they get reduced to this like 2D image which our eyes see, right? And the sort of computational tasks, the amazing computational tasks that our brains are doing, is that we're constructing 3D scenes, we're inferring 3D scenes from this 2D data, that works remarkably well most of the time. And that's why we still need human drivers, and self-driving cars aren't quite there yet because we do that job so much better. But also the fact that optical illusions exist shows you, and all these like kinds of things where you can't decide whether a certain faraway object is actually close or far or something like that, shows that this is an inference problem, and you have uncertainty about the world, what the world is actually like. I think that's evidence for humans doing something like Bayesian inference in their heads. And the specific sort of area of understanding human intelligence that I work on in my work is actually understanding how humans understand other humans, right? It's called theory of mind in psychology, and the idea is that we have intuitive theories or models of why and how other people act. We assume that other people are more or less rational and act to achieve their goals or desires, or carry out their motivations. And and then based on what we see them doing, we can figure out what their desires or beliefs or preferences are. So one way to make that formal is to say, well, let's write a Bayesian model of how humans act and what their desires are and what their motivations are. And then based on what their actions you observe, you invert that model and infer what goals they have. And I've been working primarily on writing richer, more complex models of human motivation, basically, that go beyond, I think, this sort of naive, sort of simplified model where people always maximize their preferences, because in fact, a lot of the computational problems that we do solve, imagine playing a game of chess. There's a really hard planning problem to solve. Most people who play chess want to win, unless you're playing against a kid, you want to let the kid win. But you can't necessarily infer that from what happens in a game, because sometimes you lose and you don't want to infer that you want to lose, right? And most of the time. And so how do we account for that limited capacity in human planning when accounting for people's goals and desires? And what we've turned to in the work I've been doing is writing complex probabilistic programs of human decision making, which both model human goals and also how they try to achieve those goals, and also how they might fail to achieve those goals. And doing Bayesian inference over that allows you to recover what they might have actually wanted.
Yeah, I think if people haven't seen Xuan's work on this, it's super cool. Definitely go check it out. I also often point people to it for an example of point people to the code as an example of probabilistic programs that really use the sort of modular structure that programming gives us. One last thing I'll say about, or doesn't have to be last, but the last thing I'll say about probabilistic programming is we've kind of given the sort of high level picture of why we're interested in it for like AI and cognitive science. Xuan gave a sort of one layer lower level picture of like, if you're familiar with Bayes nets, this is like a generalization of that. I'll give like one maybe even lower level or slightly like different picture, which relates it to, you might be familiar with these software libraries for automatic differentiation, where the idea is that a user writes a function in a normal programming language, and they think of it as representing a mathematical function, which they can then ask for the gradient of, and that operation on the mathematical function is automated. And that's nice because a lot of algorithms, if you go look in your like optimization textbook, a lot of algorithms tell you on like line 3, compute the gradient of your function. Right, and you can actually write up those algorithms, in as much space as it takes them to describe them in the book, because you have gradient as just an operation. Whereas before the advent of automatic differentiation, you would have had to think about your function, work out its derivatives on paper, and then go code something up that didn't really look like the algorithm. It may never even represent the function f explicitly. It might only represent the gradient of f and only the parts of the gradient of f that are needed for your computation. And so that's like harder to debug. It's harder to write in the first place. But AD makes that all much easier. Similarly, a lot of algorithms that use probability distributions, so randomized algorithms, but also like algorithms for statistical computation or Bayesian computation, are written in terms of like things you should do with probability distributions, right? Like step 2, compute the density ratio of P to Q at the point X, where P and Q are probability distributions. And having worked on some of this stuff like in MATLAB way back when, before probabilistic programming really took off, what that looked like was often like working out on paper what expressions you would need to code up, often having multiple representations of the same probability distribution at many different places in your code to represent all the different things that you would need to do with that probability distribution, sample from it, evaluate its density, evaluate the change in density when you just changed one of the arguments, things like that, right? All end up being like lots of different pieces of code. And one way of thinking about a sort of like one sort of technically grounded way of thinking about probabilistic programming is that one of our goals is you should be able to write a function that represents that probability distribution. You should be able to write it once, unambiguously specifying the distribution, and these operations that you want to do with the distribution, like sample from it, evaluate its density, evaluate the update to the density after like changing one point, should all be one-liners. that the system is automating for you based on your specification of the probability distribution. So that's kind of like the maybe an even lower level specification of this, where the other nice thing is that, as Xuan was saying, programs are a really expressive representation for distributions that go beyond the representations that we're used to, like Bayes nets or even density functions.
Thanks I learned a lot from both of your answers. That was amazing, actually. Thank you so much. But just because we are getting close to being short on time, I wanted to just point out that we're about 3 or maybe 4 minutes away from wrapping up. If there were any specific questions that you might give like quick short answers for and you want to pick them up, feel free to do that now. And I see comments in the chat about me. So thank you for Victor and Brian. I actually was thinking about like doing another data science like kind of follow-up, because there were a couple of things here and there that I would have wanted to be different. And now I feel like, oh, I guess I should do it. So thanks for saying that. And as a wrap up, does any of you have more questions that you think you can answer briefly, since we're short on time?
I'm seeing this like very question that I've asked myself is it possible to encode function signatures in a type? Unfortunately, not to my knowledge, right? Julia, it's not Haskell. Sometimes I've wanted that functionality, but I think one thing that comes with multiple dispatch is that functions have multiple signatures. And now you can't really enforce like having an input function having a particular signature. You can do a dynamic check of the method that was input possibly to your or method instances input to your function if you really want to do that. But yeah, in general, that's one thing. You know, I'm sure there may be some clever way to do this, but it doesn't feel like it really exists right now.
One of the things that was most difficult for me to wrap my mind around is how types are used in Julia, just because I'm used to, types play different roles in different languages, and I am used to like functional programming like Haskell, and they play a different role in Julia. So they're really important for performance in some cases, but it's important to learn when, and they're really useful for dispatch. In Julia, every function is its own type, which is a little bit strange if you're coming from a functional programming world, but is also really useful in the sort of dispatch and performance lenses. So I think I have seen a package that I can't remember the name of right now that does have like a kind of like function type parameterized by A and B in it that like wraps a function and then has methods on it, but I don't remember much about it. And but maybe that's something that can be Googled or asked about offline.
All right, just because now we are at time, and I don't want to keep you longer than the scheduled time. Is there like maybe one final thing that you really want to answer, but we couldn't get to? Is I guess the question. The opposite of you can answer in 1 minute.
Yeah, I was looking through. I don't think there's anything else I could immediately respond to. But yeah, I just wanted, I don't know, this has been a fun experience. Thank you, Huda, for moderating this session and everything. If people are interested in finding out, more about the work that Alex and I do, we are, I guess, both on GitHub, and we also have worked in the Probabilistic Computing group, which has its own GitHub organization where a lot of our code lives. I think we're also both on Twitter, so I don't know, at least for me, feel free
to on Slack, correct? On the Julia Slack.
As well.
Yeah. I'm also available if anyone also wants to reach out. I'm happy to answer questions. Alex and Xuan are both on Slack, or there's multiple platforms to actually keep the conversation going. So please feel free to. And aside from that, I just want to thank Alex and Xuan again for having just on a Saturday afternoon or morning, your time, my time, to just sit down and answer Julia questions. That was amazing. I learned a lot actually from, especially the conversation on probabilistic programming. I love that actually. So thanks a lot for that. And we will announce the June Julia Beginner AMA in, I guess, about 2 weeks now. So stay tuned for that, and see you at the next Julia Beginner AMA. Thanks, Alex and Xuan, again.
Thanks so much, Shuda. Yeah.
Thanks so much.
Thank you.
Thank you.
Bye.